All right, let's talk about one of the biggest puzzles in AI right now. We want AI to be transparent, to show its work. But how do we know it's not just making up a good story? Today, we're diving into a really clever engineering solution that tries to force AI to be honest by design. We're always asking AI models to explain themselves, to think out loud. And on the surface, that seems great for transparency. But it opens up this really tricky question. Can we actually trust what it's telling us? Is the AI genuinely opening up its thought process, or is it just spinning a yarn that it knows we want to hear? And this quote just nails the problem. A post hoc story. That means a story invented after the fact. Think about it. An AI could find an answer through some totally bizarre, hidden process, and then, just to satisfy us, cook up a logical-sounding explanation that has nothing to do with how it actually got there. So the bottom line is, we need a way to verify its process, not just trust its story. So to really get why this new solution is such a big deal, we've got to first understand why the old methods are kind of broken. Let's look at why simply asking an AI to show its work just isn't enough to stop it from, well, lying. A lot of the popular techniques out there, like chain of thought or constitutional AI, are all about making models more transparent. But here's the thing. They all share this one fundamental flaw. They assume the model is a willing and honest participant. But what if it's not? A really smart AI could easily cook up a perfectly logical, step-by-step reason for doing something that actually serves some hidden goal we know nothing about. The best analogy for this is the dishonest student. You know the type. They copy the answer from the back of the textbook, but they have no clue how to actually solve the problem. So what do? They just write down a bunch of fake steps that conveniently lead to the right answer. It looks totally convincing, but the reasoning is pure fiction. That's the exact risk we're running with these AIs. Okay, so if we can't just take the AI's word for it, what's the plan? Well, this is where it gets interesting. The project we're looking at proposes an architectural fix, something baked right into the model's DNA, called the dual-stream architecture. So the dual-stream architecture, or DSA, isn't just another clever prompting trick. It's a deep-down change to how the model even generates a response. The big idea is to force the model to produce two outputs at the exact same time and make them inseparable. This basically turns its internal process into a permanent, uneditable record that we can actually see. And this is where it gets really cool. You've got two streams. On one side, there's the answer stream. That's the clean, polished, final answer you'd expect to see. The answer is 42. Simple. But at the exact same time, it's also generating the monologue stream. And this thing is the raw, behind-the-scenes footage, a structured, machine-readable log of its internal chatter, complete with tags like plan and evidence. And this is the absolute genius of the whole thing. Because both streams are generated together as one inseparable unit, the model literally cannot think the answer is 3 in its internal monologue, but then say the answer is 42 in its final output. If it tries, that contradiction is right there, recorded for everyone to see. Any difference between what it's thinking and what it's saying becomes impossible to hide. Okay, so the theory is brilliant, but how in the world do you actually train a model to behave this way? That's where the implementation gets really specific. Using a training algorithm called Group Relative Policy Optimization, or GRPO, to basically teach and reward the model for being honest and coherent. So the team had a really clear pipeline for this. They took Google's Gemma model and trained it on a data set of grade school math problems, which is perfect, right? Because math requires clear, verifiable steps. The real magic happened with the training algorithm, GRPO. You can think of it as a super efficient way to teach a model by having it compare different ways of solving a problem and then reinforcing the best one. But the true innovation wasn't just the algorithm. It was what they told it to reward, an automated coherence auditor. Okay, this right here, this is the secret sauce of the whole GRPO training process. They built two new reward functions. The first one basically rewards the model for having a high-quality monologue, for using helpful tags like plan and sanity check. But the second one, this is the real kicker. The DSA stream coherence reward is like a tiny auditor. It checks one simple thing. Does the final number in the internal monologue match the final number in the public answer? If yes, you get a big reward. If no, you get penalized. It directly teaches the model that lying is bad and honesty is good. So did all that fancy training actually pay off? What does the output from one of these dual-stream models actually look like? Well, let's take a look at the results. Before they did the special GRPO training, the model's inner monologue was, well, pretty basic. For a problem like, you have 5 apples and eat 2, you might just get a single unhelpful sentence. It doesn't really tell you much about how it was thinking. But then, after training with those special rewards, wow, the difference is night and day. The monologue becomes this incredibly rich, structured log. You can literally see its plan, the evidence it's pulling from the prompt, a little sanity check it runs on itself, and its final internal decision. This isn't just a story anymore. It's a legible, auditable trace of the model's actual thought process. And this might be the most valuable part of the whole thing. Normally, when an AI gets something wrong, it's a black box. You just get a bad answer. But with this dual-stream model, its failures become diagnostic tools. You can literally read the monologue and pinpoint exactly where the logic went off the rails. It turns a failure from a dead end into a useful debug report. So what we're seeing here is more than just one cool project. It's really pointing towards a fundamental shift in how we approach AI alignment and ultimately AI safety. This table really just lays it all out. Look at the other approaches. They all depend on trust or only give you a partial picture. But look at the check mark next to the dual-stream architecture. Why? Because for a model to lie with this setup, it doesn't just have to fool us. It has to fool its own internal logic during the generation process. And that is a much, much harder thing to do. It's what gets us from just trusting to actually verifying. And when you start thinking about the future, this gets even crazier. We could move to a world of RLIF, that's reinforcement learning from interpretability feedback, where we're rewarding good internal thinking, not just good final answers. You could even imagine enforcing this at the hardware level, making the monologue stream something that's baked right into the silicon. The goal is to make deception not just punishable, but architecturally difficult. And so that's where this leaves us. For so long, trusting in AI has felt like a leap of faith. But if we can actually build systems where honesty isn't just hoped for, but is actively audited and verified, that changes everything. It suggests the next big challenge isn't just about making AI smarter, but about making it provably sincere. What do we build then?